Allegiance, please.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
I see we have a quorum. I know Director Robinette will be here. She just must be delayed for some reason. I'm sure she'll be here soon. But we've got some good news and bad news. The good news is we're all here, and we were able to get our speakers from CDM Smith to give us an update at this special meeting. Maybe it's not that bad news, but at 5 o'clock, we have a contract that requires us to give up this room to the Follies, and so we will be able to finish by 5 o'clock. So maybe that's good news. This is a different meeting. I see some faces out there that I've seen before, and you've been at regular meetings. And regular meetings, if you haven't, we normally will have a public comment at the beginning of the meeting, and then after that we go into our regular business. When we have public comment, if it's not on the agenda, we can't really weigh in on it. I was thinking that if it's to the satisfaction of the public and the board, of moving public comment to the end, because otherwise what do you have to comment on unless you actually get to hear the presentation from CDM Smith? So if I don't see any strong opposition to that, we will hold public comment at the end. And as a special meeting, you can only comment on the items that are on the agenda. Come to our meeting the next week if you'd like to comment on other things. And of course you can say anything, it's just that we can't address anything that's not on this agenda. So today, we do have a quorum, and we're all here. And if I could turn this over to Mr. Gruber, and he will then address, allow us to get an update on these projects, and then we'll all have a chance maybe in public comment, I might start it with just some questions of the speakers, maybe to move things along rather than having somebody go through 3 minutes, and I think that'll work out best for us. So with that said, Mr. Gruber.
Thank you, President Berenger and board members. I just want to acknowledge that we have invited folks from the Regional Water Quality Control Board and the State Water Resources Control Board. I see that some of the people from folks from the Regional Water Quality Control Board are here, and appreciate them coming. They've been helping with us, helping staff with the permits. We have CDM staff here, and the agenda today is the update the emergency water supply project and the various process units and the physical characteristics of the water treatment plant. I think it's important for you folks to see what it looks like. We've had a lot of talk about the project, but we want you to actually physically be able to see what the plant looks like. Hopefully we'll have some slides. Also, there's been some discussion regarding the brine holding pond. CDM Smith's going to talk a little bit about that. And then we'll follow up with the tracer study. There's been some concerns regarding the amount of water that's going to be used at the regarding the tracer study. Some of the figures that have been floated out there are just not accurate. And so CDM will talk about that and fill you in on what is involved with the tracer study. So if the board doesn't have any questions of me or CDM at this point, and hopefully the PowerPoint will work, and everything will go smoothly, and just really appreciate everybody coming today and being a part of this, and just bringing you up to date on what the board is doing and what staff is doing and what CDM Smith is doing. So with that, Mari, are you gonna be the one? And maybe you want to introduce your staff also from CDM. And I see Mike here, and I assume one of those guys are Randall. I see Saba here, so. They got the whole house here today, so I'm glad to see them all here. So thank you, Mar.
Good afternoon. Very quickly, as Jerry said, on a more specific agenda, we're going to talk about the water treatment plant and what that will do, the disposal of the brine, and then how do we make sure that the drinking water is safe through the tracer study and what's involved with that. So that is the outline of our agenda of our presentation. Who will be presenting? Our project manager, Sava Nedek, is here. And then our water treatment plant design engineer, Greg Wetterau, he's here. Our hydrogeologist, Mike Smith, is here. And our construction manager here is Randy Redmond. He's also here, and myself, I'm the principal in charge. Without further ado, let's get right into the presentation, and Greg Wetterow will come up and step through the water treatment plant.
Okay. So I can't guarantee this is going to be as interesting as the Follies after us, but we'll try to keep it a little stable here. But yeah, so this is just walking through where the plant is. So this is just north of town. Here's San Simeon Creek. Here's the state park here. And so we're going to, and these are the existing percolation ponds where the wastewater currently goes from the district. And so we'll be building a treatment plant immediately next to that. Then the treated water from this treatment plant is going to be re-injected into a new well that we put in, RIW1, and then the product water will be extracted from the existing wells here. And then I'll go through this in another slide too, but I just wanted you to see from the aerial, this is what it looks like. We also have an evaporation pond here where there's a small amount of flow, about 50 gallons a minute, that's going to be going to the evaporation pond. And then another 100 gallons a minute that is going to be directly discharged to try to keep the lagoon, the levels in the lagoon stable. So, let's see. Oh yeah. So there's two creeks here. There's San Simeon Creek and Van Gordon Creek. Currently, they're dry. They run dry during dry seasons, like right now. And then if there's rain, they'll have some flow in them. So they're pretty dry right now. We may, depending on where we discharge, there may be a small amount of flow in the creeks downstream of where we're discharging to. All right. So what we're planning to do with this emergency water supply project is to produce 300 gallons a minute of new drinking water for the CCSD customers. So this is the goal. This is going to be a new supply to get you through the drought period and any subsequent summers getting through the dry season here. It's 250 acre feet of drinking water that will be produced over the 6-month season, and then the other 6 months, the emergency supply plant will be shut down. Just wanted to go through what's happening right now. I talked about it a little bit on the previous slide, but right now your wastewater is, you've got 500,000 gallons a day on average of wastewater that goes through the wastewater treatment plant, and then that water is then sent to your percolation ponds up by San Simeon Creek. And it recharges the groundwater, and ultimately, it mixes with any underflow, and ultimately, it all makes it out to the ocean. Now, some of it does stop in the freshwater lagoons on the way there, but ultimately, all of this 45 acre feet per month plus underflow, all of that is lost to the ocean. And so what we're trying to do with this emergency supply project is try to recover this water and put it to good use instead of losing it to the ocean. So we're using groundwater replenishment to make this happen, and this is just a simplified schematic that shows you how this works. But basically, right now the wastewater infiltrates into the ground here, and again, it blends with the natural underflow. It goes out to the ocean. What we're going to do is drop this, well, there's already a well there, 9P7. We're using this extraction well to pull this water out of the aquifer, run it through an advanced treatment plant, and then the majority of this water would then go to recharge further inland, so up gradient at RIW1 where I showed you, and then it'll be extracted again for drinking water supply. So just to show you the flows here, there's about 350 gallons a minute that currently gets recharged, which is that 1/2 an MGD. We're going to be extracting 690 gallons a minute from 9P7, but 55 of that is going to be partially treated and then sent back to the perk pond. So this is the microfiltration backwash. So some of that goes right back to the ponds. 100 gallons a minute of microfiltration product water is going to be sent directly either to the creek or the lagoon to keep the level stable. And then the rest of that water then goes to the injection well. Well, a small amount, 50 gallons a minute, goes to the evaporation pond. The rest of it goes to the injection well. Of the water going to the injection well, 300 gallons a minute goes back to the customers, back to you guys, and then ultimately makes its way back here again as part of this 350. and then 185 then flows downstream back to 9P7 because just the way the groundwater flows work, the flow moves this direction. So 300 of it will go up gradient to our extraction well. The rest of it will come right back to here and keep the level stable. So really our net result is we've got a loop here with the only water that's leaving the basin is the little bit that gets evaporated here. The heart of the treatment process, what we do to keep this water safe is called advanced water treatment or advanced water purification. It's a 3-step process. So there are 3 separate barriers we're using to make sure that the water is safe for drinking. So we've got a microfiltration, reverse osmosis, and advanced oxidation. And just to go through what these are, I know, I guess a couple years ago we had a presentation where we went through some of these, so some of you guys may be familiar. I just wanted to just kind of cover it so you guys know what we're doing and why we're doing it. So we're using membrane filters, also called ultrafilters or microfilters, and they are removing essentially all, like 99 with 4 nines after the decimal place, percent of the suspended solids, the turbidity, protozoa, bacteria, anything that is suspended in the water gets removed. They do not really remove much dissolved material. So things, really small things like viruses, they partially remove, and dissolved organics, inorganic compounds, things like that, those pass right through. But anything that's suspended, and including bacteria and protozoa, will get removed. And these are commonly used for drinking water plants. They treat a lot of surface water plants to make it safe for drinking. Just to give you an idea of how these things work, they've got tiny pores that are, in our case, they are 0.02 micron. So that it's right about here. And just to show you what's larger, this is a log scale here, but this is 0.02 micron is smaller than most viruses, and it's 2 orders of magnitude smaller than bacteria and parasites. You're actually, let's see. Yeah, so you're 3 to 4 orders of magnitude smaller than the diameter of a human hair. So this is how they're able to remove all the bacteria and the protozoa, because the holes are just so tiny, everything comes out. And then this is what the surface of the membrane looks like from an electron microscope. So this is a zoomed-in version of it, and then this is how the surface looks. So extremely small pores. These things are built together in tiny straws or hollow fibers, and then the water is pushed by pressure through the walls of the straw, or through the walls of the fiber. And then there's tens of thousands of these membrane fibers that are combined in a single module, and then we'll have those on a single rack that we're treating the water with. So this is the first step. The second step is reverse osmosis. So after the water's been through the microfilters or the ultrafilters, it goes to RO, and these work a little bit different. These are flat sheet membranes, and the holes are much smaller in these. And so they're small enough that they remove all the viruses, as well as the majority of the dissolved salts, dissolved organic matter, and then also any pharmaceutical compounds, personal care products, anything else that's in the water will get removed by these. And these are, there are a few things, well, I guess my next slide said there are a few things like dissolved gases that'll pass through, but most of your dissolved material comes out. And these are commonly used for treating seawater, brackish groundwater, and also bottled water facilities. One thing to note, though, that makes this different than seawater is even though you're using the same membranes that you'd use to take salt out of ocean water, the pressure that it takes, because your water's not that salty, the pressure it takes is about 1/10 as much as what it would take to treat seawater. So this is a much lower energy process. So again, the pores in this actually are so small, I can't show you a picture of them. You can't take a picture of these pores even with an electron microscope, but they do remove particles as small as 0.1 nanometers. So that's 10 that's like a millimeter, 0.1 millimeter with 6 zeros in front of it. So it's really, really small particles that they're able to remove. They don't remove dissolved gases. So oxygen, carbon dioxide, chlorine, those will pass through these, and also some very small organic compounds. There are a few things that can partially pass through, but we haven't found any of those in the source water that we're starting with even. But just in case, we do have another process downstream to make sure that if something does pass through, it'll get removed still, and that's the advanced oxidation step. So this is barrier number 3. And here we take concentrated UV light, and hydrogen peroxide. They combine together and they produce this very reactive oxidant called hydroxyl radicals. And the great thing too is after this hydroxyl radical is done doing its job, it breaks down all the organic matter. It would kill any other pathogens that were in it, even though we've already removed them. Once it breaks down, it turns into oxygen and water. So the byproduct is just oxygen and water. So it's those of us who are environmental engineers, we kind of like that side of the process. But these things, it's very bright light. It's about 10 times higher UV light intensity than what you would normally use at a drinking water plant. So that's really the treatment process. The only waste product that we get out of this, because the RO membranes remove all the dissolved materials, we have to get rid of those dissolved materials. And so we have about 50 gallons a minute, 45 gallons a minute actually, of concentrated RO brine that we have to dispose of in some way. Now this water, it doesn't contain microorganisms. They've already been removed by upstream processes. All it really contains is a concentrated level of salt, which is about half of the ocean water salinity. So the two options for getting rid of this are an evaporation pond, where we'll put it and just let it evaporate, and then the other option is a stormwater outfall, sending it out to the ocean. And so we're still looking at both of these options. Right now we're moving forward with evaporation pond just to try to simplify the permitting, because we've got a limited amount of time to get this plant up and running. But for the evaporation pond, basically what we're going to do, we don't have enough space to evaporate, even though it's only 50 gallons a minute. Evaporation rates aren't all that great here. There's a lot of fog and colder weather, and so what we're using is evaporator blowers to enhance this. So this is basically what you'd see at a ski resort. It's like a snowmaker, and we're going to put these on the side of the pond. We'll have 5 of these blowing, and they'll improve the evaporation rate. And so we'll blow them during the day when evaporation rates are higher, and then at night they'll be turned off. And so this just shows the levels in this pond. So there's an existing pond that we're going to triple line to protect the groundwater underneath. This will be used for evaporation. Over the 6 months of operation, we expect the water level, well, 6 months, after 6 months of operation, we expect the water level to go up to about a little bit less, or about 42 feet elevation. And then we've also got room in there for if there's a 1,000-year storm. So if you had a huge storm, that would take the level up to about 43 feet. And then we've got quite a bit of headspace above that. So we've got a comfortable level that we know we can keep using this year after year without it filling up, as long as we keep the evaporators going and dropping it back down after we're done running the plant. And so with that, I guess we're going to talk about the groundwater and reinjection. So Mike is going to come up here.
Just wanted to start out, first of all, with an explanation of what is the benefit of the reuse system that's proposed out there. Under extreme drought conditions, once the basin inflow from upgradient is depleted, the flow will be coming largely from downgradient. Now, currently, the way the system operates is there has to be a gradient down towards the ocean maintained in order to produce water from the existing well field. That is done during the dry portion of the year by pumping an existing well that is out beneath the percolation ponds. This creates a drawdown and maintains that gradient from the well field out towards the ocean. That water is essentially discharged either into the lagoon or as underflow into the ocean as it infiltrates down near the beach. Now, the concept behind the use of the reuse system that we're talking about is basically, instead of controlling the gradients with 9P7 pumping and allowing all of that water to discharge, what is produced from that area is reinjected and creates a groundwater divide. The dotted line that we've got up there, essentially, you can think of this as a mound. It's a high in the groundwater table that will have groundwater flowing off to either side of that high. And what that does is create hydraulic isolation between the existing well field and the secondary treated effluent that's going into the percolation pond. Now, talking about the tracer test, we have a tracer test that will be commencing within the next week at the site. The objective of this is to determine empirically in the field, to provide a field demonstration of how long this water that's being re-injected at the new injection well, RIW1, resides in the ground. The objective of that is to allow it to equilibrate and get some additional treatment that will occur in the subsurface as it migrates after the highly advanced treatment that occurs, as it migrates back up towards the existing production wells. Now, the tracer that we're using is the bromide ion. The bromide ion is very similar to a chloride ion like you have in a common table salt. We are injecting 10 parts per million of bromide in the form of sodium bromide, very similar to the sodium chloride that exists in table salt. Now, the source of the water, it will be pumping at wells SS1 and SS2. Those are existing wells in the CCSD well field. That will be recirculated after addition of the tracer for a 30-day period back into RIW1 to build up this mound and get this recirculation cell going. Now, the water will be recirculated for a total of 67 days, because one of the things that we need to verify is under the state regulations, we need to have a residence time of 60 days in the groundwater aquifer to get this additional treatment. As we talked about the last time, our modeling analysis shows that we'll have an excess of 120 days, but you know, there's always uncertainty with models. We need to demonstrate this in the field, and that's the objective of this field tracer test, is to demonstrate physically that we have adequate residence time. Now, during the test, normally at this time of year after a long drought, this down valley gradient would be maintained by pumping the existing well 9P7 that lies in the area of the percolation ponds, and then discharging that water out to the stream where it essentially discharges to the ocean. So during the duration of the test, that additional pumping and loss will not be occurring. We'll also be recirculating a good portion of that water from the injection well back to the production wells. During this 67-day test, we'll have a total of about 44 million gallons, or that's about 130 some acre feet. Now, of that, our estimates of the loss to the ocean that would occur is about 20% or 25 acre feet over that little over 2-month period. Now, those additional losses that occur basically are because we're creating a mound during the test that's increasing the gradient, which you can think of as increasing the velocity of groundwater flow. So we're allowing a little bit more water to move out in the subsurface. But that's partially made up by this not having to do the gradient control pumping at well 9P7. I'm going to show, you've seen the locations here. RIW1 is the new well that has been put in. There's also a new monitoring well, because as part of this whole process to validate and verify how fast groundwater is moving, we have 2 monitoring wells that will be used. Monitoring well 1, MIW1, which has been installed, and then in addition, the existing production well, SS3, will be used for monitoring purposes, not for production during the test or during emergency operations. Now, what I'm going to show you is, this again goes back to the model, but it'll be kind of an animation that shows the extent of the tracer. The color fill area basically represents a modeled estimate of the area over which the tracer has spread, this amended water. And if you watch the upper right-hand side, this will happen at 10-day intervals. Basically, as the radius of this increases, you have a very rapid increase in the size of area that's covered because it's close to the well, and essentially the volume increases as the square the distance that you move out. So there's more volume available in the aquifer. And there's a gradient that's being induced here because if you think about it, we're injecting water at RIW1. That results in a rise in water level. We're mounding at that location. At the same time, at SS1 and SS2, we're drawing the water levels down. And so that's the driving force. And so as we progress through time at, for example, at day 30, that's where we cease injection of the tracer chemical. And that's about the time that we're projecting that that front will reach MIW1. As we move out with time at approximately day 60, we should hit about the location of SS3. And then by day 70, you start to see the effect of injecting just the produced water without the tracer. We're starting to clear out the tracer near the well, and at day 70, we also cease reinjection in RIW1, and the whole 454 GPM that's being produced goes back into the distribution system for CCSD. With time, you can see that we still are causing movement of the tracer back towards the well, and we're projecting at about 140 more or less the tracer front. And this color fill area is basically where we have 5% of the injected water hitting there. So we'd be at a concentration of 5% of the 10 ppm at that point. So with that, that's a summary of the tracer test that's planned for this start this coming week.
Mr. Gruber, would you like to, should we open it up? I think that since we have the Savas here and other people, and did the State Water Resources Control Board, do we have some representatives from them?
I don't
Okay.
know.
We wouldn't be asking them any questions, but we invited them here in case they wanted to get a feel for the public, but I think that CDM Smith did an excellent job of solving this. So if it's all right with the board, and if people wanted to ask some additional questions, I think we can just do it. If you have a question and you want to ask, and if I could ask Mari to be the moderator of this particular thing. Any questions from the?
We have Dave LaCarl from Regional Water Quality Control Board, but would the board want to answer questions, ask any questions first?
Yeah,
Maybe
sure.
if the board has some questions, or do you, it's up to the president. I defer to the
couple questions,
president.
but Mihaela, maybe you can ask a quick question.
I noticed that you mentioned ocean alcohol, and no, that isn't actually in the plans right now, because I called the permitting agency, and they said it wasn't. Mr. DiCarlo, I believe is his name. So how will you know if the toxic brine pit, because it isn't just brine, there are other chemicals, correct, is failing, and you would then have to shut things down and then apply for a NPDES permit for an ocean outfall? Sounds complicated to me.
Yeah, and it's not a toxic pit. I mean, this is just regular groundwater. This is groundwater that's been concentrated. So we've we're taking the water and squeezing 92% of the water out, and then the other, all the dissolved materials are now in 8% of the flow. So it's more concentrated than it was. It's about 10 times more concentrated than it started out. But it doesn't have anything new in it. We're not putting any industrial contaminants in there. It's just the water that we started with, more concentrated. So we're going to be running the evaporators in the evaporation pond, and over time, as it gets more and more evaporated, you're going to reach saturation levels of salt. So it will be very salty in the evaporation pond. But if we did do an ocean outfall at some point, then it's half the salinity of the ocean. There shouldn't be anything in that water that would be hazardous for ocean discharge, or that would really prevent us from discharging it.
Do any of the other board members have a question? Or, okay, let's listen a little bit. There's a person back here. So, yeah, and turn the mic on, by the way, Bob. Okay.
Your colleague mentioned the 1,000-year flood for capacity in the tank. What consideration has been given in any of this construction for earthquake?
Yeah, so these are all of the construction that we're doing is zoned for the earthquake conditions that we have here. So this is meant to continue operation during an earthquake. The biggest thing, the most likely thing to break during an earthquake is obviously pipes, things that are run like that. And so, if you guys got a big earthquake, there could be some issues out in the system, but the plant itself is built for earthquake conditions.
I have a question. Can you tell me the elevations of the wells that you're putting in, the source well and the injection well, compared with the receiving? Give us an idea of the gradients.
Yeah, the surface elevation of the existing wells is around 25 feet or so above sea level or at datum. And they're both, it's a very flat area up in where these wells are being put in. Oh, the gradient between the two, there will be about an 8 to 10 foot, potentially a little bit more depending upon drought conditions between the mound and the drawdown around the wells.
Yes, I wondered, with the 67-day testing, this keeps pushing back the time when water will be available from this source. When do you expect, after testing and so on, that this can actually be put into effect and we start getting water?
Right now, our schedule has us starting up in November, and the 67 days doesn't actually delay that. We're ordering the equipment, these things are getting pulled together, and we're getting it out to the site as quickly as possible. So things are going on, multiple things are going on at the same time.
But November is when you're expecting that the first date that it could go online?
Yes.
I think Mr. Butterfield, and then Bob, let's get this person up here.
Yeah, I have a number of questions. Brine disposal, how do you expect to anticipate disposing of it? And that was a very good question about the elevation of these wells. The county emergency plan suggests that we should be planning for a tsunami run-up. They call it run-up zone instead of an inundation zone now. I guess it's on. So the county emergency plan says we should be planning on a 24 to 39 foot tsunami run-up. So you can plan maybe for a 100-year storm. I don't know how you plan for tsunamis. We certainly have seen the effects in Japan. Seems like it hasn't happened in a while, but we shouldn't forget about that.
Well, okay, so for the brine disposal, right now, there are two options that we're working with. The one that we're moving toward right now is the evaporation pond. So we've got about 50 gallons a minute of brine.
Where does it go from there?
To the air.
You said there will be dissolved, there will be evaporated solids at the bottom of this thing?
Yeah, so over time, the salt will crystallize, and you'll form salt at the bottom of this. It'll take 100 years for it to fill up, but so the water evaporates, the solids stay behind, and you will get a crystal formed at the bottom. And at some point, they'll have to clean it out. Depending on how frequently it's run, it may not be run every year.
Okay, and have you calculated O&M costs?
We have.
Did you include the 30% rate increase that PG&E is asking for between now and 2016?
Yeah, so should I do?
I'm sorry?
So 15 cents per kilowatt hour is what we
But
used.
there are different categories of users.
Right.
Is that calculated in or not? Okay, it is calculated.
Yep.
Thank you. Will we come up to this person here, Bob?
Oh, I have a good one. How many operators are required to run this plant? We've read in the paper that CCSD is low on
Bob?
manpower.
Yeah, so the,
We have a
number five.
question up here. Thank you.
Yeah, so it's five operators. Actually, during the initial operation, the Department of Drinking Water is going to be requiring 24-hour operation or 24-hour operator presence
The guy in the
just during
purple-
initial period.
purple sleeves?
And so we'll have 5 operators total during that period. But then over time, it may only be operated during the day, and the number of operators could decrease. Yep.
I noticed you were talking about a 100-year storm and the way the weather has been, what happens if that doesn't happen, and the extreme drought supply keeps up. What's going to happen with well 9P7 and our water supply?
Well, and that's the beauty of this project because, you know, we had to have room in the brine pond actually for the 1,000-year flood, not just the 100-year. But if that never happens, the beauty of this is that this is a recycle project. So the water that we pull out makes its way back, and I don't know if looking at the mass balance, it's going to take a long time to get back there, but there's 350 gallons a minute that go into the basin, and we're sending 300 gallons a minute off when we're all done. And so really the only water loss is that 50 gallons a minute that we're evaporating. And so this is 300 gallons a minute that you guys don't have right now. So if you don't do this project, then you won't have that 300 gallons a minute. And so if the drought continues and you don't have a new source of water, you guys are going to run out of water. And this gives you an extra 300 gallons a minute that you're losing out to the ocean right now.
Okay. And Bob, we have one person over here. And then, if we could then go back to the man with the blue shirt.
Is this plant something that exists and it's being shipped here, or each element is being configured per this project? And then do we know the ratio, the cost of actually the plant and the labor, at what rates this building of this facility is going to cost? Has this been shared with anyone?
Yeah, and I'll let Bob respond on the rates. As far as what's the equipment being built, this is being sized for your plant. Now, some of this, we were able to find existing equipment that was already the right size for what you needed, but other things are being purchased specifically for it. Yeah, all of this is coming in specific, and it's coming in different pieces. We've got different modules, different containers that are all being brought in, and then we're going to pipe them together.
And I can answer the rate question. As you all know, we're currently under a Prop 218 process right now, and that Prop 218 process and the amount of dollars indicated in there is the maximum amount that it would take to run this facility. The board has the ability to, with those rates, reduce them at some point in time based on funding from the Prop 84 that we've applied for. If you've been following the county Integrated Regional Water Management Plan and the Prop 84, you know that we're really kind of on top of the list, and we're one of 17 communities identified within the state of California in the possibility of running out of water. We've applied for $3.75 million, and that's really a policy decision with regards to the rates. But the Prop 218 that is out there right now will fully fund this project without any assistance from the Prop 84 or the Integrated Regional Water Management Plan. Now, as you know, the board is committed to this project. We've spent $2 million out of general fund reserves of your money so far, and so there's been $2 million allocated from the CCSD already. The original project that was proposed when we were working with the Army Corps of Engineers was in the $15 million range, and so this project is coming considerably less than that. So I hope that addressed the questions relating to the Prop 218 and the funding for it.
We're kind of in a silent mode here where we can't, we can't advertise one way or the other, but facts we can always give. There's a man back there in the blue shirt. Oh, batteries are dead? Anyway, in general, maybe you can, the IMD is on the agenda on the 24th, and we can't discuss that this time. If there's a question that relates to the brine holding pond, or the tracer study, or the emergency supply project, that's all we can talk about. Oh.
Yeah, absolutely. It's the,
You wanted a noise. Yeah, repeat the question,
questions
because he
about
doesn't have a mic
level
yet.
of noise and
Okay.
whether or not sound enclosures have been included for this. A lot of, much of our equipment is going to be inside the containers, and also a lot of it is set back. These are at the percolation ponds. It's set back quite a ways from the edge. Really the loudest thing that we're going to have here will be the spray evaporators, the snow blowers, those things. Those actually have produce a fair amount of noise, and so we're building enclosures around them to reduce it and to meet the noise limits at the edge of the property.
Right, I understand that. However, they won't be operating at night normally,
Right.
whereas the advanced water treatment plant will be. So the nighttime noise is probably a concern to the state park.
Yeah,
and to others.
Right, and the nighttime noise would only be coming from the treatment plant, and that's much, much lower than the noise from the air blowers. Again, we've got sound attenuation around the blowers, but at the treatment plant, these are low horsepower pumps. It's a relatively small plant, and there shouldn't be any noise outside the site.
Okay, thank you. The other question relates to the evaporation pond. Is there going to be an odor related to this water, especially as it becomes more concentrated? I know the feed water that we've used for landscaping for a while here does have an odor to it, and I assume that that will become more concentrated as you go through this process.
Yeah, well, that one will be tough to know for sure, and it's hard to model odors. Because a lot of it has to do with just natural process, what grows in the pond on its own. The good thing is when the wind is blowing toward the state park, we've got a weather station there, and the blowers will be turned off during that period. So they'll only be blowing in the air when the wind's blowing
Well, no, but
inland.
the pond itself will still be emanating some odors, I would assume.
Shouldn't be any different than what's already in the freshwater lagoons, because the things that we're concentrating are what's in the freshwater lagoon already.
Bob, we have one more up here in the red, this woman in the red dress.
Hi. This may sound like a pretty simple question, but it's confusing to me. The water that you're going to be using and treating and then injecting, is this our sewer water? Is that what that is?
It is partially. It's a mixture of the treated sewer water that's infiltrated and then natural underflow that goes through there. So what percentage is sewer water and what percentage is other water is unclear until it's been run for a while, but this is why we've got all those different treatment processes. So Kurt Souza from formerly Department of Public Health, now with, they call it, Department of Drinking Water. He's here in the back, and he can, they've got regulations for what we call potable reuse. Just because a portion of this water is going to be coming from the secondary effluent, we've got these multiple barrier treatment processes to remove anything that might be in the water. Now, the samples that we've taken from the well suggest that the actual wastewater origin of it is pretty small right now. We didn't find any of these, the pharmaceutical compounds and other things that you normally see in wastewater, but we're treating this with all these processes just in case, just to make sure that if there is anything in there, it all gets removed and that the water's safe.
Now, if a lot of the water is coming from the sewer, in order for it to get to the sewer, it first has to come out of our taps and into our toilets and down the sink,
Right.
correct?
Yes.
So do we So we're counting on, what is it, 350 something or other acre feet or gallons per minute or whatever. You're counting on a certain amount of water coming from the wastewater in order to run it through this whole process. What if we don't, I mean, if we don't have that water?
If you're not using water, there won't be any water coming back.
So if
but
we're not using any water, but if we don't have any water to use from the outset, so that's what what I think I'm a little confused about. If our wells are all so dangerously low, and you're counting on a certain amount of water in order to run this whole thing you're building, and we don't have enough water coming from our existing wells to create enough wastewater to treat,
right.
then
So this is an offset. What this does, you can never run 100% on recycled water because you have to have something else coming in. And so you guys, right now, you have 350 gallons a minute of wastewater. We're only sending 300 gallons a minute back. So you have to have, and right now, you guys, 75% of your water use is in-house. So 25% of the water is gardens, things like that. So 25% of what goes into your system for drinking water does get lost. So you have to overcome that 25% and the other 50 gallons a minute. So you are going to you're going to have to rely on your existing sources of water. You're just going to have 300 gallons a minute less that you're going to have to rely on. So it's a huge reduction in how much water you have to pull in.
All right,
but
and
I think the water I guess my question is do we have enough water to operate this? What I understand is we're going to be running out of water. What if we run out of water before this is up and going and you turn it on and...
What this does is it buys you a lot more time, several more years until it finally does rain, because eventually it will rain. Eventually the drought will break. And this gives you a lot more time until that happens.
right. And Bob, I think Laura, is it Laura? Anyway, Stuart hasn't asked a question yet. Anybody else that hasn't asked a
I was
question
wondering
yet?
why you're keeping your options open as to whether or not you're going to deposit the RO permeate or filtrate, whatever, into Van Gordon Creek or into the LIWs. Why are you keeping your options open there? You're talking about either discharging from the existing pipe from 9P7 into Van Gordon Creek or into the lagoon injection wells. Why are you keeping those options open?
Well, one of the challenges that we did a test putting the water into the creek, and it all just kind of infiltrated right away. It didn't make it to the lagoon, and so we're still studying this. We're trying to determine the best way to maintain the best level, to maintain levels in the freshwater lagoon. So that's really our target. No, we're not. We're not planning to use LIWs. It's just a matter of where in the creek we discharge.
Here's a person that hasn't asked a question, then I'll bring it back to the board.
I heard in your original talk on this that you use the word try to, and you say it shouldn't. And is this a foolproof plan, or is this an experiment? Is this something that we know that we can count on, and when it costs this much money, that it's money in the bank, or it's questionable?
Yeah, and I have to apologize. I'm an engineer, and so I always speak in caveats.
Well, I'm not
I know. If something is 99.99% sure, I say it should work. So this is something that we have done before multiple times. It is a reliable process. It's a process that is producing water in Orange County right now. They've got a 70 million gallon a day plant. There are 4 other plants running in Southern California. We know this process works. It's a safe, reliable approach to supplying new water.
Okay, thank you. Anything from the board? Any question? I have. What, do you have? No, I have one. I saw your model of the tracer study, and it looked like it hit one of our wells, but it looked like you went out to 700 days or something before it was. How confident are you that in 90 days or in 60 or 70 days we're not going to have any bromide in the? How confident are you in the success, the model?
Well, that's one of the reasons for the safety factor in using a model to assess, because, by their nature, models are simplification of a natural system, and that's why this 2 times safety factor, the well was placed to give us in excess of 120 days of residence time. So very confident.
So you're very confident. And
Yeah.
is there a way we could petition to avoid the test so we don't lose any acre feet? Can we get someone to, anyway, it's a thought. Anyway, and the other one, we are putting water into the lagoon, even during the tracer test. Is that correct? We're trying to keep that freshwater lagoon there?
Not a direct discharge. The well 9P7 will no longer be pumping because we're maintaining the gradient control with the injection. However, there is still the percolation pond water that is supporting discharge to the lagoon right now. So yes, it will still continue during the tracer test.
Okay, good. Well, thank you very much.
Robinette.
Ms. Robinette, please.
Thank you. Just a little bit back to just maybe a little more clarification. When you're talking about the mixture of water that's going to be treated through the 3 different stages, and some is already treated from the sewer, and then there is, of course, the salt water and the fresh water from the aquifer, what's pretty much the percentage of each of those?
Do you have, did the model project the long-term?
Well, we had the numbers up on that. We had the numbers up on the slide. Approximately, 187 is recirculated. Because of building the mound, some of that water is lost and will go back down to be recovered at well 9P7. Most of the infiltrated water from the percolation ponds will ultimately make it into that recovery well, and the remainder of that water will be either basin underflow or, under extreme drought conditions, a reversal of flow from areas that are down gradient of the percolation ponds.
So it's hard to put it's difficult to put a strict percentage on it because.
Can you clarify what you mean by that? You speak another language.
But you want me to give it a try?
Yeah.
Yeah. So the issue is it's difficult to say exactly what percentage is going to come from what source because it depends on how much it's been raining lately. So right now there's very little underflow. So as we run right now, the majority of the water, probably 2/3 of the water, would be coming from the secondary effluent, and then the rest of it would. Some of this also. We're treating this water with advanced treatment. We're injecting it. A lot of that, 184 gallons a minute, is going to make its way back to the well. So some of the water we're starting with is going to be already advanced treated, and we'll be running it through the advanced treatment again. And then there is the natural underflow. So it's really hard to put on a strict percentage on how much is coming from each source, but a large majority of it will be coming from the secondary effluent, most likely.
And one other thing, in the future, when we when we'll be able to do direct injection, which will probably happen in a few years, I would think, and maybe I'm wrong, we would be able to directly use that water rather than having it, or is that not in the concept?
So Department of Public Health is developing regulations for direct potable reuse, which could allow you, other cities like Los Angeles and San Diego are looking at taking their effluent, their wastewater effluent, and treating it directly and putting it back into their system. That's not something that you guys really need to do at all here because you've already got your infiltration area. So it's an option that's available to people who don't have a good groundwater aquifer like you have. But as far as right now you're putting it into the ground twice. You percolate, you pull it out, you treat it, you put it in again. You might not have to put it in twice in the future. It all depends on how these regulations unfold.
Okay, I understand. Maybe one or two more questions. Sir, with the light blue shirt.
My question is, the 300 gallons per minute, how does it converts to acre feet? I mean, once this is running, can we go back to, can the community go back to its old habits and start to water the gardens and take the showers and, you know, not having a bucket, you know, in a shower, or how does it changes our situation?
Currently, Cambria has approval from the county for an emergency coastal development permit. And the terms of that permit, in order to operate this facility, will require Cambria to be under stage 3 drought declaration. There is another permit application in for the permanent coastal development permit, which that would change the operational parameters and the times so that potentially, depending on what happens in that process, Cambrians could potentially go back to watering. But right now, under the terms of the emergency permit, you still would have to remain in stage 3.
So the 300 gallons per minute, how many acre feet is this? You know, 1.3 acre foot per day.
So
250 acre feet over
Over
6 months is what that is in acre feet.
We use, to put things in perspective, in a normal year, we'll use less than 800 acre feet. So this is meant to guarantee that we're going to be able to use that amount that we've had in the past. And I got somebody in the back, not Jim Webb. Jim Webb hasn't had a chance to talk.
Thank you. I had a couple questions about 9P7, that well. On the one, and I'm basing these comments out of the Title 22 engineering report. There, page 18, you talk about that there is virtually no wastewater present in the water in 9P7. And you speculate that the well may ultimately prove to not be under the direct influence of wastewater. And my question about that is, where do you think the wastewater is traveling, since we are depositing a large amount of wastewater in the percolation pond? If it's not showing up in 9P7, where do you speculate this water is traveling?
Well, we have some monitoring data from several wells that are downgrading into the percolation ponds, and there we do see significant fingerprints associated with the secondary effluent. And so a lot of it is moving in that direction, but when 9P7 goes on to long-term pumping as part of this, we'll be changing those vertical gradients, and you'll cause additional vertical movement in the vicinity of that well instead of down gradient where we're seeing it now.
Okay, and just one quick follow-up question, if I could. On page 62, you mentioned that the water quality measured in 9P7 is high quality before treatment, complying with every drinking water MCL, which is maximum contaminant level, and secondary MCL. If this water is basically drinking water quality, is there some reason why they don't just immediately use that water as part of a municipal system?
Yeah, and the concern is we don't know what it's going to do over time as we pump that well, and we're expecting to get more and more secondary effluent in there. So if we were going to use this as just a drinking water supply well, well, first of all, it'd be challenging to permit, but you'd have to run it for 2 years, and to get 2 years of data while it's running to confirm that the water quality doesn't change, and we don't have 2 years. So we have to do this extra treatment, assuming that it becomes primarily secondary effluent, just to be safe, so that we can get the emergency plant in by November.
Okay, I have it. Question, how did we end up with a 250 acre foot project here? That seems like a lot of capacity for an emergency, because when we were talking to the Army Corps engineers, a permanent with the 4650 build out seemed to be the 250 acre feet. Why such a large project just for an emergency use that only the local people can use to get us out of this situation?
The CSD has a pumping permit on 372 acre-foot from San Simeon Creek over 6 dry months. So 250 acre-foot is way below what the permit is. So we don't have, it is already under the restriction, it will be reduced volume. And this is what meets the immediate emergency needs for Cambria community. This is one in the other, exactly. So you, when you go with permanent project, then you will be having right to pump 372 acre-foot. So it will not be 300 gallons per minute. It will be 495 gallons per minute. Yeah.
Sorry. For the permanent, the long-term permit, you'll be in less of a drought under that operating scenario, so there will be total combined more water available to look at as compared to the severe drought when you're in a stage 3. There is a permit application applied. We don't know what will happen.
Who should be next, Jim?
I think there's if you can find a new person back there, would you?
Tracking the board.
There's somebody waving their hand back and forth.
Which, in the back row?
In the back row, yeah. The guy with the blue hat.
Thank you. Referring to the tracer test, the 130 acre feet that are going to be consumed, is that potable water, or will we recover that? That's a lot of water going down the drain if it's potable.
Yes, it is potable water because the source of the water that's being re-injected is from the existing well field. However, the ultimate loss that we're looking at is more on the order of about 20% of that, or around 25 acre feet, because of continued production after the tracer test. And then in addition to that, when the system comes online later in the fall, then that water that was injected will be recovered at well 9P7 and then go through this entire process.
So basically, we're going to get 100% recovery of the use.
With the exception of that loss of 20% that's due to increasing gradients, which is going to drive more water out to the ocean.
I just have a couple of quick questions. One of them is that in your documentation, you talk about all of the chemicals that are going to be put into the sprayer, and that's, if you see a picture of it, it sprays about how many feet? 100 feet in the air, 200 feet in the air, and you have 5 of them. Those chemicals are going to be flying into the air, and it's near and adjacent to the park, the San Simeon State Park, and I want to know what the overflow is going to be, the overspray is going to be, how far those particles are going to flow. And the other thing is the amount of bromides and chemicals and metals and things like that that are going to be in this brine, left in the brine, all these toxic chemicals that could influence the groundwater, the creatures, the water, the streams, and the ocean, because it's going to go out there too. Thank you.
Yeah, so what, now we aren't using any chemicals in the sprayers. That any inorganic material or anything that's in the water is what was already in the groundwater to start with. So in our treatment process, not in the actual blowers, right? So we add a few things. We add chlorine to disinfect. We add sulfuric acid to prevent scale on the RO membranes. We add a phosphate-based polymer to help prevent scale. So we have a few things that are added in low concentrations. I mean, it's like 1 to 2 milligrams per liter of that antiscalant. And so we do have a few of these things that are added, but they're very low concentrations. In the RO, and a lot of them, well, so in the RO brine, those will be in there along with anything that was already dissolved in the source water. They will concentrate, everything will concentrate, but we're focusing on avoiding overspray. So these things don't spray up 150 feet, they spray out 150 feet. So they will spray out over the top of the pond, and we've got weather stations there, again, to prevent, if the wind is too high and it's going to create overspray, we're going to turn these things off. And so we're only projecting that they're running 40% of the time, because we are going to have to turn them off if the wind is blowing the wrong direction or the wind's blowing too far, because our whole point is to keep the spray, to keep the solids 100% within the pond footprint.
Can you touch on the modeling, just real quick, the modeling and the safety precautions with regards to the 15% and things like that, that we are working with regional, regional water quality control board? Because I think it's, what I'm hearing is there's safety concerns, and I'd like the public to know the modeling that you did regarding those sprayers and the overcapacity, really, that we're designing to address some of those concerns.
Sure. Yeah, you want to answer that, Saba?
We're very concerned about the overspraying and...
I'm sorry.
Or you can come up here.
Yeah, good idea.
We're very concerned about overspraying with our spray evaporators. So we work with manufacturer, and we have, at the same time, we're developing a very sophisticated spray evaporation model. The spray evaporation model will be finished these days and will be available, will be public document, so everybody can see and check what we put this in this evaporation model. This evaporation model takes in account all climatological conditions in Cambria, very specific to this micro location where this is going to be located. This model will be used to initially set up the ranges for the running, for the jet that this spray evaporator will push out. We are projecting to go up to maximum to 200 feet from the west berm of the pond towards the east. And we have the meteorological station that will follow direction of the wind and the speed of the wind. So whenever speed exceeds certain value, it will shut down the whole system. As Greg mentioned, we're projecting to run only 40% of time. The other thing, manufacturers can be very willing to sell their equipment. So whatever they propose, their efficiency, and they propose their efficiency is going to be between 30 and 60%. We're cutting this by half. So we're taking only 15% efficiency. Jerry, that is a question you asked on the spray evaporator. So we consider it way more conservative than it will be.
I have a question too, a little bit about, you said that when we develop this brine, it's only going to come to a concentration of half the value of the ocean. And what constituent products would be in there? Is it just salt, or help me understand that?
It's again, whatever's in your groundwater right now, it'll just be about 10 times more concentrated. So it's a lot of sodium, a lot of chloride, and then calcium carbonate, a little bit of magnesium. Those are going to be the major constituents.
And are those constituents normally going to the ocean anyway? We're just going to concentrate it first?
Yeah, all the salt that you would, if you had an ocean discharge for this, you would be putting salt that was already going to the ocean through the groundwater, and you'd be putting it in a concentrated brine. But it's the same dissolved solids that would have otherwise gone as underflow would be going as a surface discharge.
How about any additional chemicals?
So there's a small amount of 4 milligrams per liter of chlorine that we're adding, and 2 milligrams per liter of that phosphorus-based or phosphate-based antiscalant. So there's a few things that are being added, but when you've got 1,300 milligrams per liter and you're adding 10, 15 milligrams per liter of a few other things, the majority of it's what's already in there.
Okay, well, thank you. Ms. Robinette?
Well, I just wanted to follow up on that too. And the conversation from the audience and with you here today is very valuable. But everything that you are doing is highly monitored and regulated by the state agencies, isn't it?
Yes.
Thank you.
I'm trying to find people that have only spoken once. There's a fellow in the... in a gray shirt back there, yeah. And I don't mind, well, when we adjourn.
About the impact of the project on the current availability of non-potable water from the rodeo grounds there. We're depending upon that for landscape water. I'll repeat it. My question has to do with availability of the non-potable water from the rodeo grounds, which in this stage 3 emergency we're depending upon for landscape watering. Is this project going to impact the availability of that water?
I'm going to have to, that is an agenda item. That's a very interesting agenda item on the 24th, next Thursday, and we're going to, we'd like to have a kind of a roundtable discussion regarding that. I don't think we can address that. Other than we have, you know, during this, we still have water coming down the creek, so we still have water in our wells, and during this test period, we've determined that there's enough, I shouldn't say this, is Jerry around? Anyway.
I can answer that.
Yeah,
the answer
Bob.
should be no. I don't think it'll impact
Yeah.
it, so should be absolutely
Yeah,
so.
good answer. How about
Which would you-
one more from this person here with the purple, and then Laura, and then and then we'll stay on subject.
Yes, earlier you used Orange County as a model of the refluent plant. And what are you doing about direct injection with concerning the other metals and solids left behind in the water table?
That's a good question.
Actually, could you repeat it? That are in the water that we're starting with, or yeah. So we're removing more than just salt. You know, all the organic material, anything that's dissolved in this water gets. There really isn't mercury we haven't measured measurable quantity of mercury in the source water. If it was there, it would get removed by our process, but we didn't measure any in there. And so, you know, if there are other organic compounds or inorganic, anything of that sort, this process is designed to take them all out. But they're really, in this water, when we're starting with it, as was noted earlier, it's already meeting drinking water standards.
Okay, Orange County was started, what, 1970s? So this has been a model that we're following?
Yeah, Orange County evolved. I mean, it started in '76. But we upgraded it in 2008, and so the process that we have here is the 2008 version of Orange County, not the 1976 version.
Bob, we have a woman in the yellow.
Some years ago, we had a oceanfront condo in San Simeon on Balboa Street. Most of the time, it was very nice staying there, but sometimes for about 3 days, we got the awful stench from their treatment plant there. It was terrible. Are we going to be sure that we don't have the same thing by accident on this plant?
Good point.
Well, the good news is that most of our treatment process is fully enclosed. So we're taking water that's already in the percolation ponds, and we're treating it in closed pipes, taking everything that's of concern out and sending it back into the groundwater. So the actual treatment plant won't have any impact on odors. Now, we did talk about the evaporation pond, and that we haven't modeled that specific to the issue, but again, the plan for that is to not run the sprayers when the wind is blowing toward the ocean, because they would cause a lot of problems. We're containing all the overspray within the pond, and so we'll be turning that off if the wind is blowing too far or blowing the wrong direction.
Ken, if you have one brief question, and then Jim Wilson, which is to your right. Oh, maybe
Sure. Excuse me, sorry, that was loud. So I've read over the CCSD's Urban Water Management Plan. I've read the Water Use Efficiency Plan. I've read the Urban Drought Guidebook from the Department of Water Resources. And unfortunately, your Recycled Water Master Plan. Hang on. I haven't answered my. You can't hear this? No. Oh, sorry. Okay, let me start again. So I've read the Urban Water Management Plan, CCSD's plan. I've read the Water Use Efficiency Plan, the CCSD's plan. I've read the Urban Drought Guidebook, which is produced by the Department of Water Resources. And I would like to be able to read the Recycled Water Master Plan, the CCSD's Recycled Water Master Plan, but it's not on your website. So I mention these things because there is an alternative to this plant, and that is water conservation, which many of the folks, probably everybody in this room is conserving water, but the CCSD is not.
No.
And wouldn't it be cheaper to upgrade the water treatment plant to bring it in compliance with Title 17 and have utilize the $4 million we've already invested in the purple pipe system that runs up Moonstone Beach Drive? And all of these plans that I referred to call for metering of non-potable water for uses other than domestic. There's no great new infrastructure, no sprayers, no nothing like that involved in doing it. And people who need to tanker water for their irrigation can do that. It's metered, you pay for it. The rest of us don't pay for water we don't use.
Thank you. Mr. Wilson? Oh, no, you didn't want to comment? Okay. No. All right, well, Laura, one. And Mark Kramer. Mark Kramer, would you then use that as an announcement? Then I don't have to, okay, good. Okay, Laurel Stewart, I think. Okay. And then Mark Kramer will finish it up. And I'm quite impressed that the amount of information we've been getting. It's no.
Right here, which one?
Laura, Laura. Yeah, Mark Kramer. Laurel's first. Let Mark go first, and then we'll get Laurel's first, and then Mark will finish it up.
To go back to my original question, do I understand that the lagoon injection wells are not a part of your plan? Why are they still in the plan?
Give it to Laura. And then Bob, give the mic to Mark Kramer, and that'll be it.
So this has been a very fast-paced project, and so a lot of different moving parts. And it was in there at one point, because at one point we were looking at the two options, and it remained in there simply because we had not made this decision prior to the ISM&D being posted. That's all.
Okay, do you have any experience injecting waters into freshwater lagoon and checking on the invertebrate life and how it's affected? Bioaccumulation of, for instance, you're adding ammonium hydroxide to protect the filters in the microfiltration. You're doing that upstream. It'll come out in the backwash. I understand the backwash is going to the percolation ponds, but
correct.
The ultimate product, do you have any experience with dumping it back directly into such a lagoon?
Mike?
And the biological effects?
We haven't done a toxicity test of any sort for this. Basically what we're doing right now, the water that's going into the lagoons is underflow. It's from the percolation ponds, and it underflows through the soil and into the evaporation pond. We're taking that same water, and we're adding chlorine and ammonia at a small concentration, like 1 milligram per liter of ammonia and 3 milligrams per liter of chlorine, and that then goes through the microfiltration just to filter out suspended solids, and then it would go back there. So the only thing that's different from what we pulled out of the ground, what's already going there, is that small amount of chloramines, so chlorine and ammonia, which will be consumed very quickly when it hits any organic material in the water. So we have not done a toxicity study, but the difference between this water and what's currently going there is extremely small.
And Mark.
We will be doing an adaptive management plan to determine those lagoon levels and maintain them. So, and to make sure we're maintaining them afterwards, just so you know.
I kind of beg your indulgence because my name is Mark Kramer, and Saturday I sent some communication information both to Jim and to Jerry in connection with concerns from many, many Cambrians for the several groups that I'm in. And as a result of that, I sent an email to about 150 of people on my email list that are concerned, and many people are here today because of the information which I've gathered from talking to them. And even though it's not directly related to your project, if you could bear with me for 3 minutes, I would appreciate it. I've been living in Cambria full-time for 16 years. When I moved to Cambria, there was a sign on Main Street saying, "Water is our most precious product, conserve it." And now I'm worried that this year I may turn on the spigot and nothing will come out. It's kind of like an Apollo 13 problem. Paraphrasing, Cambria, we do have a problem. So I am here for two primary reasons, and I was not aware of the fact that we were going to have this presentation today when I sent my letter, but thank you for bearing with me. I am here to lend support to our CCSD board and the management team as they come up with a temporary and permanent solution to bring water to Cambria, and also to ask the board and management team to come up with the best objective way to keep our community informed as to how long our current water supply will last based on the best available use, and include this data in the same section of the Cambrian on a weekly basis. Now, today's presentation was extremely informative. I must admit that a lot of it is over my head, and I would like to think that it's probably over a lot of people's heads as well. The one thing I did hear was that we may not get any of this water until November, okay? And that's something that sticks in my craw. Anyways, many are here today, and many have sent me emails offering their views on the difficulties of coming up with a specific, objective way to inform the community how much longer our existing water source will last. Now, shortly after the mandatory Stage 3 alert was implemented, CCSD management stated we had enough water to last until October based on the current water usage that the community was using during the prior 2 months. That was a good starting point, and hopefully that can be reported in the Cambrian. In addition, many of my associates would like to see a status report on the estimated timing of when the alternative sources of water will become available, just like you talked about today. To the extent that recent resignations have occurred during this difficult period, we hope that today's turnout of support will get back to the CCSD employees, which will hopefully reflect a reduction in their stress levels. One response to my letter came from Jim Crescenzi, who said that it is long overdue that Cambrians recognize that the days of cheap water are long gone at this time in California. He says that we need to step up to the plate and solve our problems, not just constantly criticize and delay action. The cost of an inadequate supply of water to our local community would be excessive and would cause harm for many working families, as well as those of us who are retired. In conclusion, Houston and the Apollo 13 teams solved their problem, and closer to home, the Cambria community put aside their differences, came together, and bought the Fiscalini Ranch 14 years ago, and there were differences of opinion. Water is our most precious product, and we now ask the community to do the same, to put aside their differences and pray that our CCSD team will come up with a solution. Thank you.
Thank you. Director Robinette. Director Robinette has a comment, and then I'll turn it back to, okay, and then Director Rice, and then followed by back to Mr. Gruber.
Okay, thank you. I just wanted to share a little bit, and actually it's certainly timely with that presentation. I do think that we are on the right track. I think we all wish that this would never be, that we weren't in the situation we're in, but I think that most people here are very supportive and want a solution. And then I was looking at the latest on the NOAA reports for weather coming up for our state, and I just wanted to share a bit of it with you. We've heard quite a bit about El Nino, and we put a lot of our hopes in that kind of thing, And sooner or later, we all know that cycles do happen, and yes, someday we will have rain again. We all know that. But this is the latest report from July 10th. And this is from Michelle Mead, who's the warning coordinator meteorologist with the National Weather Service in Sacramento. And she said the chance of a strong El Nino is not favored, and forecasters anticipate El Nino will peak at weak to moderate strength during the late fall and early spring. She said that for Northern California, San Joaquin Valley, the estimate for a weak to moderate, that there is little correlation between El Nino events and above normal rainfall. She said the El Nino right now is not a slam dunk as far as helping us with our drought scenario. And I think we want that, and I think we were some pretty optimistic about that, but I think where we're going has to be where we have water insurance. Thank you.
Thank you, Director Rubin. Rice?
Just a couple of questions, a couple of little technical things that are pretty much the only technical things that I'm probably actually qualified and educated to speak to, which is there was a slide where you talked about there's 0.5 million gallons per day that gets put to the percolation pond, and then you said 45 acre feet a month. How does half of a acre foot times 30 days equal 45 acre feet? I just want to make sure that maybe I misunderstood. I want to make sure there isn't some weird math error that's going to cause us some problem, like when they use centimeters instead of inches on one of the space.
The 500,000 gallons equal 500,000 gallons per day. If I multiply this by 183 days, which is 6 months dry period, and divide this by 325,000 gallons per acre foot, I got 250 acre foot. If I divide this by 6 months, that is how I get this 45 gallons per, actually more accurately, 46.4 acre foot per month.
Okay, that was some new math on me. Why are we doing the UV 10 times higher than what normally would be used for drinking water?
Stayed up here. Yeah, so the UV is not being used primarily for disinfection. It's being used for removal of constituents of emerging concern, pharmaceutical compounds, personal care products, anything, which they won't be in the water. It's a redundant barrier to remove anything that does pass through the RO. There is, the Orange County plant had trouble with a compound called NDMA, nitrosodimethylamine. It's an organic compound that's formed, it's a disinfection byproduct. And they were finding it when they didn't have UV, they were finding it in their wells downstream of their plant. So the UV got put in there to deal with that. So it's a redundant barrier, and it has to be a high dose because it's removing organic compounds. But at drinking water plants, all you're trying to do is kill bugs. So it's a lot easier.
Okay. And can you tell me, this is probably a more complicated question than you can answer in a minute or two, but what we'd be doing differently if we weren't under such a severe time crunch?
If you had enough time, you could run 9P7 for a couple of years and find out what percentage of the water is actually coming from wastewater. And your treatment process could look a lot different depending on how much of it is wastewater. The other thing we could do is we're not taking any credit for disinfection from the percolation ponds because there really isn't a good model out there for how much disinfection happens in there. And so if you had more time to monitor and model, then you could get additional credit. You might be able to get rid of some of the treatment steps in here. But just because of the time crunch, we aren't able to do that.
So we're essentially getting we're setting up basically everything so we make sure we cover every eventuality because we don't have time to actually do
it would take at least a couple of years.
To optimize whatever treatment process would be needed for our actual water.
Yeah, and also if you did anything less than what's being done right now, it would be the first time it's been done in the state. So it would take quite a bit to convince
Right,
Division of Drinking Water.
I understand that, yeah.
And Greg is correct, but if you go back to our presentation in March on the hydrogeologic modeling, the modeling does show a lot of impact from the percolation ponds. So we doubt there would be much change to the treatment process. I mean, Greg's right, it potentially could have reduced a little bit, but we don't think it would be changed that much, so, because of that modeling.
Okay, I'm sorry, just a couple more little technical questions. They're not
No,
about
please.
on the evaporation pond, how much does that actually hold, and how, I mean, you kind of talked a little bit about 100 years before you'd have to clean it out. Is that, how much water does that hold? How much did the discharge, will we be able to?
Yeah, so that was more on the solids, because we are, when you evaporate, you leave the solids behind, and they will start to accumulate over time. It's a very, very slow process. I mean, you're probably not going to wait 100 years to clean it, but it would be full to the top at that point. But it probably could be 20, 30 years until you would have to clean the solids out of it. But the amount of water it actually holds, what we were modeling was we were assuming it fills for 6 months, and then you evaporate for 12 months, but you're only filling for 6. And so we had a graph up there, we had a figure that showed how high the level reaches. So you've got some additional capacity in there that you could potentially, I mean, the plant is designed and planned to run for 6 months. You have space in there that you could run it for a couple extra months, 2 or 3 extra months before you overflowed it. But, we want to keep that buffer in there.
So the evaporation pond is large enough for us to run it for 6 months and have the discharge, the briny discharge, be put into the evaporation pond?
Yes, you could, even without evaporation, you could run for a full 6 months without overflowing it. But
how much water does it hold? I mean, how much fluid water does it would it hold?
What's the capacity?
I'm sorry. I just really, this is one of the concerns that I have, that we run out of space to store the. Yeah, sorry.
What our calculation shows that we're going to run, as Greg says, for 6 months. At the day when we start running and dumping into this evaporation pond, we'll start evaporating with evaporators, mechanical spray evaporators. I think Greg did calculations that by 6 months, after 6 months of operation, you're going to have the volume that would be disposed into the pond is about 11 million gallons. However, since we continuously evaporate, the remaining will be about half of that, a little less than half of that. So in additional 6 months, we will be continuously evaporating until we reach end of this 1-year cycle. At that point, I think Greg did calculations that the salt at the bottom will be at 350,000 milligrams per liter, or 10 times more than ocean water. And it will be about 3 to 4 inches. If we leave this a little longer, then the entire water will evaporate, and you are going to have probably ½ inch of solid salt at the bottom. Does it answer your question, Director? Thank you. Yeah, the volume that we have inside, I think the slide shown minutes ago shows that after 6 months, we're going to have about 5 foot, close to 6 feet deep water level into the evaporation pond. Otherwise, it's about 9 to 10 feet deep. Now, Regional Water Quality Control Board requires from us to have capacity into the evaporation pond that will sustain 1,000-year rainfall for 24 hours. And this is about 10.2 inches of the water volume inside that we can have. Then on top of this, we have to have 2-foot freeboard. I think it's for waves that can be preventing the brine to be spilling over the berm. So I think and on top of this, I think we have some actually plus more than otherwise would be required. Thank you.
These technical questions kind of bring up one thing that I don't even know how to address the question, because I'm not even actually sure exactly what the question is. But when I looked at the process that the Army Corps of Engineers goes through when they're doing a project, one of the steps, in fact, one of the things that was delaying them with our project is there's a bunch of different peer review, and there's an internal review where they have to send it to a different district and they review have we had any peer review of this particular project other than Mr. Greshams and CDM Smith? I mean, I really want to make sure that what's happening is we're getting the best that we can get. And this is not meant anything against the professionalism of CDM Smith, but this is a process that the Army Corps of Engineers developed for a reason, I'm assuming. And so that was, and I don't even know if that's a particular answer. The other question that I have is mostly for Mr. Gruber and Mr. Greshams, which is, what I heard, not necessarily explicitly, was that even though we're not losing more than a 27 acre feet out of the aquifer or the basin, we're actually not going to be able to use those wells during the testing. Is that true? And do we have enough to balance between, because I know right now we're balancing between the two basins to try and make sure that we don't do anything damaging to either one of them. Am I getting that correct, that during that 67-day tracer test, we won't be losing the water out of the basin necessarily, except for that little amount, but can we actually put it into the system during that 67-day period?
We'll have well SS1 set up to be able to provide about 150 gallons a minute during the test period. We're not going to want to use that unless we absolutely had to, but it is able to put water into the distribution system during that testing period. It does complicate the calculations and everything that goes with the tracer study. So our preference is not to use it, but it is there as a backup to the Santa Rosa well field.
And so it's there as a backup. Can you, I'm sorry, this is one of the few water translations I can't do in my head. The gallons per minute to say per day, gallons per day. Do you have an equivalency? 150 gallons per minute is about how many gallons for the day? About? Just ballpark. Thank you. I'm sorry. It's one of the few I don't know.
Zaba, how much is
Off
it?
the hand.
So about
So
two-thirds of an
1.3 acre foot? What, you
You
said
said
430? So, okay.
245, 440.
Thank you very much. Thank you very much. Thank you very much. So we would be basically relying on Santa Rosa Creek primarily for the water supply during the tracer test because it provides better test results, more accurate for the tracer test. Yes? Can we afford to do that?
Yeah, that's what we plan on doing. We also, the Filtronics plant, we also have the SR3 well from the lower Santa Rosa aquifer that we plan on using.
And you feel confident that we will be able to supply water?
We monitor this on a daily basis, and so as of the 7th of last week, we had about 46 feet of water in Santa Rosa. It's tight. I mean, it's. I'm not going to sit here and say I feel absolutely comfortable. That's why we're doing this project. I mean, we're under. Right. It's a pretty difficult situation right now.
The timing is rough.
The nice part about running the SR4 well and running the SR3 well is those are all fully automated now. The SR3 well is a brand new well. Along with the SR1 well, we pretty much ripped those out and put submergibles in. I'm going to get too technical, but the SR3 well is interfaced with telemetry, and so is the SR4 well now. So it's all automated and runs off the elevations and tanks. So I want to get this system up and running.
I feel you there. I think that we all do. And the last question that I have is does this project increase our overall reliability of our water supply, or does it just essentially a fallback for during drought time? Because we're at 90 to 95% reliability based on the Kennedy Jenks and all of those studies, past studies. So does this increase that?
I would say definitely yes. I think it's I've said this. It's a permanent solution for a temporary situation under emergency conditions. That's kind of what I've been keep saying publicly over and over. And it also gives you a option, you know, to have a diversified water portfolio under drought conditions, where we're answering, you know, your question about, well, do we have enough? Now it just allows us to really, as the gentleman said in the audience, when are we going to be able to start living a normal life again? When is the community going to start being able to not haul buckets around and things like that? And so it diversifies our portfolio, but but it's also going to give us a much broader water portfolio.
Yeah. And I echo that. We have, they say how much water do we have left? Well, in a way we have plenty, but if we take it all out and we have subsidence or we have saltwater intrusion, we may not be able to have it the next season. So this is definitely water insurance as far as I'm concerned. And I think that I got to thank CDM Smith and this is a short term. We put this together real quick. Obviously, you've been working on it. I think the presentation was extremely successful. I think the reason they were able to do that is because there were prior investments. There's been a lot of money spent on this. The Army Corps of Engineers has spent a lot of money. We took a lot of those work products, which are several feet in depth and many, many hundreds of thousands of dollars, but that investment was now be able to be used and used right away by CDM Smith to come up to speed, and doing a project in less than 6 months is fantastic. Our permit requires that it's up by then, so we will have it up by then. And I think that they confirmed the fact that $8.8 million is a not-to-exceed number. I know that in the thing that we put out, we added another 20%, but it will be done in that amount. I think that there's a level of transparency that's here. This is being streamed live, I believe. I know I had a couple constituents that said that they're looking in on this, so it's being streamed live. AGP videos this, and it's on channel 21 on Friday nights and whatever on Saturdays, but you don't have to wait for that. You can go to slow span and you can download the entire video of this particular proceeding and all of our proceedings for the past several years, and we'll continue to do that. Also, in the mailer that went out, I think we mentioned the website. We have a website we're updating weekly. As we get information, we're going to give you information on the progress of this project. So that's. And will that presentation be, well, it's going to be streamed. So if you wanted to stream it and download it and see it on AGP, you can. So we're trying to be as transparent as possible. We do have another meeting next Thursday and hope to see it. I do have one comment, perhaps. Yeah, go to the mic if you'd like to.
I'm Bill Warren. I've been here for 26 years.
Yeah.
It seems to me Mark Kramer's question needs an answer. Using the present amount of potable water we are now, how much water do we have? Is it going to last a couple of weeks, a couple of months, or till Thanksgiving, or when?
Well, I think we should have an accurate answer for next time, or you want to address it right now?
What I would like to do, and I think Mark's, and I got Mark's email, I think it's a good, we'll include it in the engineer's report for the 24th board meeting to see if we need to refine those original projections with regard to when we think we might be out of water. Staff has never felt comfortable saying, you know, it's like this is when the world's going to come to an end, Armageddon type thing. But we would like to be able to provide that information on an ongoing basis to the community if we need to refine those calculations. And I think that's a very good point, Mark. There's some other things that Mark sent out on email that I think also we need to, you know, we like to hear from the public. There's things that, if there's information that you're not getting, that you think would be valuable in helping in this process, I'd like to get that information. Just one quick thing, I'd like to thank Kirk Souza and David Licaro from the regulatory agencies for taking, and their staff for taking time out of their busy schedule to come up here and spend some time with us today. So thank you, and really appreciate that.
Let me echo that. I tell you, these guys are working so hard. The state, you know, we're just one little pea in the pot here, and they're working very hard, and they're trying to do as much as they possibly can. If they'd like to. No, I'm afraid if they stand up, they're going to get questions. But thank you guys for being here. I really appreciate it. And for Mr. Warren, you know, originally we were thinking about having water through October, and now we're using almost half of what we were using before, so I'm sure it's well into the November timeframe or beyond. So we're not going to run out, you're not going to turn on your tap and not have anything at all, but I do think we should update it with appropriate caveats. With that said, I will adjourn.